Hey guys, time to start chapter 7 on quadratic functions. So let's take a look at what we have. The function for a quadratic in vertex form is f of x is equal to a times the quantity x minus h all squared. So let's try to sort this out and see what we can figure out what each of those variables are. So if we look at the next slide and we compare the graph x squared to 2x squared, let's see what the graphs look like. The blue graph is our original function, f of x is equal to x squared, but g of x is equal to 2x squared, or the red, and you can see what 2 does. 2 makes it narrower, but it doesn't change the vertex at 0, 0. So what happens if we compare half x squared and a negative half x squared? You can see the data in the table, and in the graph you can see that when we use a negative sign, the parabola is down, or we call it frowning, and the blue is positive or opening up. But since the since the 1/2 is the same in each, the width of the parabola is the same. So let's take a look at the functions of the form ax squared. So if you have a quadratic where you have a variable in x squared and the coefficient a, the graph is at the parabola, the vertex of the parabola is at 0, 0. And if a is a large number, the absolute value of it, then it is a steep or narrow parabola. If it's closer to 0, then the parabola is wide and open. So those tell us some things as we go forward with this formula, what a will do to our graphs. Translating a graph vertically in up and down shifts means that we need to subtract or add to the x squared term. So if we look at x squared minus 3 and x squared plus 3 with our parent graph x squared, this is what happens. The plus 3 moves it up 3. The negative 3 or subtract 3 moves it down 3. So what happens when we move it left to right? Now look, we're talking about x minus 5, that whole quantity squared. So this is the part inside the parentheses. Here's where it gets a little bit tricky. It looks like a negative 5. And so our brain is going to want us to think about it moving to the left. But because the general formula is x minus anything, it actually moves it to the right. So when you have x minus 5, it moves the vertex to the right 5 units. So if we want to sketch a graph of y equals ax squared, then we translate or move that graph that we just made to the right if h is greater than 0 and to the left if h is less than 0. You translate the graph from step 2 up or down based on k. So if you look at this formula here, a times the quantity x minus h quantity squared plus k, each of those pieces, a, h, and k, tell you what to do with the original graph. Let's take a look now at the function f of x is equal to a negative quantity x minus 4 squared. So a is equal to a negative 1, h is equal to 4, because again that subtraction is part of the general formula. So the 4 is just positive in this case. Very confusing. You have to be careful. And because there's nothing added, then k is equal to 0. So the blue graph is our original parent graph, our minus x squared. Then we shift to the right 4, and our graph of the function f of x equals negative quantity x minus 4 quantity squared is the red parabola. What happens if we now take a look at, sorry, I'm trying to get to the right. I'll back up a second. Hey, this is putting that same formula in your graphing calculator and verifying your work. Always an excellent idea. So the vertex of the graph of a quadratic function in vertex form is the point hk. So now, the reason why we like this form versus ax squared plus bx plus c is because it automatically gives us the vertex. So we are given the function 1/3 times x minus 5 quantity squared plus 3. So we know that we're going to graph 1/3 x squared. Before I even show you, because 1/3 is positive, you know this parabola is opening up. And because it's 1/3 and closer to 0, you know it's kind of a wide parabola, not narrow. H is equal to 5, so we know that we're going to move it to the right 5, and K is 3, so we are going to move it up 3. So look at our original blue graph. We then take this blue graph and we shift it to the right 5 and up 3, but we do not change the width. That allows us to make sure that we're keeping the same width and we're just shifting or translating. That is important as we go forward. Now we're going to work on modeling quadratic equations. So if we look at this data, the percentage of women ages 16 and over who work for the various years starting in 1980. So 51, 54, 57, 58, 59 going up, and then 59.3, 58, 56 going back down. Our gut might tell us that this is a parabola since it went up and then down. So we are going to find the equation of the function. We're going to find the vertex, and then we're going to estimate what happens in the year 2021. So put this data table in your graphing calculator and do a scatter plot. You notice it does in fact look very much like a parabola. Now, we could use the graphing calculator to do a quadratic regression and get an equation. However, it will give you the equation in standard form, ax squared plus bx plus c. It will not give it to you in vertex form. So we're going to learn another way to find the vertex form. So to find the function, we pick the highest data point we were given, which is 2260. We are going to assume that that is the vertex. So we plug 22 in for h and 60 in for k. Now we pick another point, randomly another point, and in this case they chose the point 5 and 54.5. 5 is the x value or the t value, and 54.5 is the output. So that allows us to rewrite the equation as 54.5 is equal to a, we substitute 5 in for t, minus the 22, that quantity squared, plus 60, so that we can find a. You are going to square negative 17. You are going to now subtract 60 from both sides, divide by 289, and you find that a is equal to a negative 0.019. We can now find the equation. So the function of t is equal to a negative 0.19 times the quantity t minus 22 squared plus 60. If you plug that into your graphing calculator, you can see that it fits your model very well. So we will use this equation to now decide what happens when, so we're going to decide what some things happen in the future. This slide is actually showing you that what 2260 means is 60% of women ages 16 and over in the year 22 years after 1980 or 2002 is the highest percentage of women working according to the model. So the vertex is the maximum, so it's the maximum number of women working during this model. What happens when t is equal to 41, which is 41 years after 1980? About 53.1% of women ages 16 and over will work according to this model. So to use a quadratic model in vertex form, create your scatter plot Imagine the parabola comes close to the highest data point. Although it's not necessary to select a data point, it is convenient to do so, so that's usually the easiest way. Then select a non-vertex point to substitute in to solve for A, and then replace A in your equation. I hope this helps you get started, and I'm praying that you are safe and healthy, as is everyone in your family. We could use prayers, as our oldest daughter on the east side of the state has been battling a fever for about 8 days and has been unable to get tested due to the limited testing supplies over there. So I'd appreciate any prayers you have for her and her quick recovery. Bye. I really miss all of you, and I hope you're doing great.